Yes, good morning. Today we are going to start this Milne Thompson method for finding the analytic function. So in the previous classes we have done that if f of z is equal to u plus iota v, so if u is given, we found v by using the CR equation, that is the harmonic conjugate of u. What are those CR equations? That is del u over del x is equal to del v over del y, and del u over del y is equal to minus del v over del x. So with the help of these two equations, we have found out our v, that is the harmonic conjugate of u. And if u is given, you can find out the harmonic conjugate, that is u. Alright, one thing more, that if u is a harmonic function, then v is the harmonic conjugate of u. But if v is a harmonic function, then its harmonic conjugate is minus u. I have cleared you in the previous classes this. Alright. So what is the way of finding our analytic function? Now you know your u, you know your v, then you put these two values over here, that is u plus iota v, you get your fz. But fz comes in terms of x and y, because u is a function of xy and v is also the function of x and y. Milne Thompson method is a very convenient technique of getting our function fz in terms of z only. So this method introduces our function fz in terms of z. How we do this, I will tell you later on. Next, there is a note over here. If fz is equal to u plus iota v, then okay, there is another way of getting our function fz. How is that? What is the derivative for fz? That is f dash z is equal to del u over del x plus iota del v over del x. Now if u is given, then also we can find f dash z in terms of u only, that is the u partials, because I can change this second term to del u over del y. That is, your f dash z will become del u over del x, because here v is not given, only u is given. Then this can be changed to minus iota del u over del y. So if we are not interested to find the harmonic conjugate v, we can use this equation for finding our analytic function f of z. Now this equation is for f dash z. Similarly, if v is given, then we can use the equation as f dash z is equal to, here now I change this del u over del x to del v over del y plus iota this del v over del x. So if v is given, I should use this equation to find f dash z. Now if I integrate this f dash z, then I will get the required analytic function fz. So here there is no need of finding that harmonic conjugate v. We just use CR equation over this formula and get our value for fz. Now here also this fz comes in terms of x and y, but we need to have this fz in terms of z. So before integration, you should change this f dash z to before integration this f dash z should be in terms of z only. Then I integrate this f dash z with respect to z. Then integrate f dash z with respect to z and get your final required solution for fz. Now how to change the terms in z. Now I will explain you in this content. This is a very important method and very convenient method to find. First is for Cartesian coordinates, z is x plus iota y. Now z becomes x if y is equal to 0. So what you have to do is you put y equal to 0 in fz or f dash z and replace this x by z. So what is the conditions for that? Number 1, put y is equal to 0, and the second condition is replace x by z. Then you have to integrate f dash z. Next one, if your z is a polar coordinate, in terms of polar coordinates, if z is given, that is if z is equal to r e the power iota theta, then z becomes r if theta is 0. So now what are the conditions? Number 1, put theta is equal to 0, and second one is replace this r by z, and then finally you integrate with respect to z. Now there are some of the examples so that it will be more clear to all of you how to use this Milne Thompson method. This is quite interesting. Show that the function u equal to x cube minus 3xy square is harmonic and find the corresponding analytic function. Okay. First you have to prove that this u is harmonic. U is x cube minus 3xy square. To show this is harmonic, we just have to show that this u satisfy the Laplace's equation. So let's check. Del u over del x comes out to be 3x square minus 3y square, and the double derivative again is 6x. If we derivate with respect to y, we will get minus 6xy, and the other derivative is minus of 6x. Now when you add these two, you will get your solution that is equal to 0. So del square u over del x square plus del square u over del y square comes out to be 0. Hence, u is a harmonic function as it satisfies this Laplace's equation. Okay. Next, now to find the corresponding analytic function. Now here there is no need of finding the harmonic conjugate v. We just use that f dash z equal to the term I have explained you in the previous page. Sorry, we just have to use this equation, that is f dash z is equal to del u over del x minus iota del u over del y, because here u is given in this question. U is given. Okay, next. So now if u is a harmonic function, now we have to introduce our analytic function fz. To introduce that function, I have to write that since u is a harmonic function, thus u is a real part of some analytic function. It is a remark also. Sorry. That remark is, if u is a harmonic function, then it is a real part of some analytic function in the domain D. So now what is that analytic function? Now I suppose that let f of z is equal to u plus iota v be the required analytic function. Alright, now my f dash z is equal to, we know this f dash z is del u over del x plus iota del v over del x. Since u is given, so I should change this. Sorry, this is changed to be minus iota del u over del y. You just have to learn this. Either you learn this formula or you learn that two equations for getting f dash z in terms of u or v. Okay. Alright, so what is del u over del x? That is, we have found that is 3x square minus 3y square minus iota, what is del u over del y? That comes out to be minus of 6xy. So this is 3x square minus 3y square plus iota 6xy. Now see, my f dash z comes in terms of x and y. Now to change this in terms of z, I have to use the Milne Thompson method. So I should write by, I use the term empty for this, by Milne Thompson method we put y is equal to 0 and replacing x by z. So f dash z becomes 3z square. This term is 0 and this term is also 0. Now integrating f dash z dz is equal to, integrate this 3z square dz, that comes out to be 3 z cube over 3 plus constant, which is equal to z cube plus c. Now integration of f dash z will be f of z. So fz is z cube plus c. This where c is a constant. Easy, so convenient to use this formula. Okay, next. This is how we find the analytic function for the given harmonic function. Now the other question is, show that u equal to sin x cos hyperbolic phi plus 2 cos x sine hyperbolic y plus x square minus y square plus 4xy satisfies Laplace's equation and find the corresponding analytic function. The same steps we are doing now. To show this satisfies the Laplace's equation. So what is u? U is sine of x cos hyperbolic y plus 2 cos of x sine hyperbolic y plus x square minus y square plus 4xy. So let's start. Del u over del x. This is cos x cos hyperbolic y minus 2 sine of x sine hyperbolic y plus 2x. This is derivative for y 0, so this is plus 4y. The second derivative, this is minus sine of x cos hyperbolic y minus 2 cos of x sine hyperbolic y plus 2. Now del u over del y. This is sine of x sine hyperbolic y plus 2 cos of x cos hyperbolic y minus 2y plus 4x. The other derivative, sine of x cos hyperbolic y plus 2 cos of x sine hyperbolic y minus 2. Now you see del square u over del x square and del square u over del y square. If we add these two, we get 0. So del square u over del x square plus del square u over del y square is equal to 0. Hence, u satisfies Laplace's equation. So, u is a harmonic function. In question, it may ask that show u is a harmonic function or show u satisfy the Laplace's equation. One and the same thing. Alright. So if u is a harmonic function, then again I should write u is a real part of some analytic function and let f of z be the required analytic function. So again we use that equation. We know f dash z is del u over del x plus iota del v over del x. So now again u has been given, so this is del u over del x minus iota del u over del y. What is del u over del x? That is cos of x cos hyperbolic y minus 2 sine of x sine hyperbolic y plus 2x plus 4y minus iota. What is del u over del y? That is sine of x sine hyperbolic y plus 2 cos of x cos hyperbolic y minus 2 of y plus 4x. So many terms, right? So if I use the Milne Thompson method, this will be very easy for you to evaluate. So by using Milne Thompson method, I should put y equal to 0. The terms will be reduced now and replace x by z. So f dash z will become, see, this is cos x, this is 1 because cos hyperbolic 0 is 1. So this is cos of z. Here this term will be 0 because sine of hyperbolic y is 0 plus 2z. This term is 0 minus iota. This term is also 0. This term will be 2 cos z. Minus, this is 0, this is 4z. Okay. So now integrating this f dash z, this integration of f dash z dz, this is integrate cos of z plus 2z minus 2 iota cos of z minus 4 iota z dz. You will get integration of cos of z, that is sine of z. Then this is z square. This is minus 2 iota sine of z minus 4 iota z square over 2. And finally you will get sine of z plus z square. You take minus iota common and you will be getting 2 sine of z plus 2z square plus constant. Plus constant where c is the constant. Where c is your constant. Okay. Next, third, show that the function uxy is equal to e the power x cos y is harmonic. You have to show this is harmonic and determine its conjugate. Now here question is asking for the conjugate. So we have to find its conjugate and the analytic function also. So what we will do? We prove that u is harmonic and find the harmonic conjugate and then add these two with u plus iota v and we get our function fz. That is the first way of finding your fz. Now uxy is equal to e the power x cos of y. To show this is harmonic, so I should find del u over del x, that is e the power x cos of y. Del square u over del x square is again e the power x cos of y. Del u over del y is minus e the power x sin y. And del square u over del y square is minus e the power x cos y. If we add these two terms will cancel out and addition will be now, the sum is 0, that is Laplace equation is satisfied. So u is a harmonic function. Just as done in the previous questions in the previous class, we are to find the harmonic conjugate v. Now u is a harmonic, so let we suppose v be the harmonic conjugate of u. Okay, then अगर ऐसा हो जाता है तो u plus iota v be analytic. This is analytic because if fz is analytic, then u and v are both automatically harmonic. Now here v is a harmonic conjugate of u, so u plus iota v is analytic. Okay, So let's use our CR equations. By CR equation we know कि हमें first equation positive लेनी है, that is del v over del y is equal to del u over del x. सबसे पहले हमने पॉजिटिव वाली लेनी है. So del v over del y will be e the power x cos y. Let it be 1. Now integrating this with respect to y. So this is v is equal to e the power x cos of y dy, which is e the power x. What is the integration of cos y? That is sine of y plus phi of x. Okay, so v is e the power x sine y plus phi x. Okay, now the second CR equation, that is del u over del y, which is minus del v over del x. Now we differentiate this and use in this, the right hand side. So this is e the power x sine of y plus phi dash x. What is del u over del y? This is minus e the power x sine y. So both the terms cancelled. So phi dash x comes out to be 0, or phi of x is equal to constant. If we integrate phi dash x, then we will get this as constant, where c is a constant. Put this phi x back to this equation, that is your second equation. So this is v is equal to e the power x sine of y plus c. Now finally I got v, that is the harmonic conjugate. Now f of z is u plus iota v. U is given in the question. So what is u? This is e the power x cos of y plus iota v is e the power x sine of y plus c. So by now we have to change this fz in terms of z. So by Milne Thompson method, put y equal to 0 and replace x by z. So fz is equal to e the power z, cos of 0 will be 1 plus iota, this term is 0, c. So this is e the power z plus iota c. So there is no need of integration, because we have only add this u and v and put that values in this fz. So this is already fz, so there is no need, there is no f dash z, so no need of integration over here. So this is a required analytic function. The other one is, if fz is u plus iota v is analytic and u is given x square plus 4x minus y square plus 2y, find v and hence fz. Now see, here fz is given to be analytic. So there is no need of showing that u is a harmonic function. Because if fz is analytic, then u and v both are automatically harmonic functions. So there is no need of showing this. In the previous questions, the fz analytic is not given. Okay, here fz is analytic, it is given in the question, so there is no need of showing u is harmonic. Okay, it is automatically harmonic. So what is your u? U is x square plus 4x minus y square plus 2y. We just find v over here. So by using CR equations, okay, by CR equations, the positive one is del v over del y is equal to del u over del x. So del v over del y is equal to, differentiating u with respect to x, this is 2x plus 4, that's it. Now integrating, we will get v is equal to with respect to y you should integrate. This is 2xy plus 4y plus phi of x. Okay, so the second equation, that is, this is the first one. Now the second CR equation, del u over del y is equal to minus del v over del x. So this is, what is del u over del y? This is minus 2y plus 2 minus, what is del v over del x? We differentiate this, that is 2y plus phi dash x. Fine. So this is minus 2y cancelled out. I will be getting 2 is equal to minus phi dash x, or phi dash x is equal to minus 2. On integration I will get phi of x is equal to minus 2x plus constant. So v will be 2xy plus 4y minus 2x plus the constant. So I finally get my v. This is u, this is v. So fz becomes u plus iota v. U is x square plus 4x minus y square plus 2y plus iota. V is 2xy plus 4y minus 2x plus c. Now by using Milne Thompson method, we put y equal to 0 and replace or replacing x by z. So fz is equal to z square plus 4z. This is 0, this is 0, this is 0, this is 0. So this is minus iota minus 2 iota z plus c. Iota c. So this is z square plus 4z minus, taking iota outside, 2z minus c. Okay, so this is your required analytic function. Next, here are some exercises for you. Show that u is a harmonic function. Obtain an analytic function fz with u as its real part. So you are to show over here u is a harmonic function. Just show that and obtain your analytic function fz by using f dash z. Now your f dash z comes out to be e to the power minus z minus e to the power minus z into z. You have to integrate this and you will get fz is equal to integration of these two terms. I'm doing this integration for your final answer. You obtain f dash z on your own. So this is integration for this is minus e the power minus z minus. Now there are two terms. Take the first term and the second term, that is first term integration of second, that is e the power minus z with minus sign, minus integral derivative of first function, that is 1, into integration of second function, that is e the power z. This is minus e the power minus z, this is plus z e the power minus z, minus integration of e the power minus z dz, which is minus e the power minus z plus z e the power minus z minus e the power minus z plus. So this is z e the power minus z plus constant. Okay, so this is your required f of z. Find the analytic function given u equal to cos x cos hyperbolic y. So hint is given, you find your fz. Find the analytic function fz where v is cos x cos hyperbolic y. So f dash z comes out to be this and your fz is this, the required solution. Now the last question is, that is a very important and very good question, a very nice and expected question. Find the analytic function fz for which u is half log x square plus y square and f of 1 equal to iota is given over here. So you find your fz and then put this z equal to 1 and your fz is iota. Put that value and get your solution. So let's start. U equal to half log of x square plus y square. We have to find the analytic function fz. Now here fz analytic given, so there is no need to show. Okay, wait, what is the previous question? If fz is analytic, here it is given that fz is analytic, but in this question the language is somewhat different. Find the analytic function fz. It is not given that fz is analytic. We have to prove that first. So for that, for introducing this analytic function fz, I have to prove first that u is a harmonic. Then only I will introduce fz as analytic, the required analytic function. So for introducing that analytic function, I have to show first that it satisfies the Laplace's equation, u is harmonic, and then I should let the analytic function fz. So I have to show that this u is a harmonic. So your del u over del x comes out to be, this is, if you calculate this, you will get x over x square plus y square, and del square u over del x square comes out to be y square minus x square over x square plus y square whole square. And okay, I'll write here only del u over del y comes out to be, similarly in similar terms, by symmetry I am writing y over x square plus y square, and del square u over del y square, again by symmetry I write x square minus y square over x square plus y square whole square. Now if you add these two, you get their sum equal to 0. So adding both the equations, we get del square u del x square plus del square u del y square is equal to 0. Thus u is a harmonic function. Without showing this U is a harmonic, you cannot let your analytic function Z. You have to show this first. Therefore, U is a U is a real part of sub-analytic function. Now let fz equal to u plus iota v be the required function, analytic function. Where v is a harmonic conjugate of u. Harmonic conjugate of u. Okay, so then what is f dash z? We use del u over del x plus iota del v over del x. Since u is given, I should change the second term in terms of partials of u. So this is del u over del x is x over x square plus y square minus iota. Del u over del y is y over x square plus y square. Now before integration, I should change this in terms of z. So by using Milne Thompson method, put y equal to 0 and replace x by z. So f dash z is equal to z over z square, this is 0, minus this whole term is 0. Okay, so this is finally 1 over z. Now integrate this. Integrating f of z will be equal to integration of 1 by z dz, that is equal to log of z plus constant. Now it is given that f of 1 is equal to iota. See, it is given that f of 1 is equal to iota. Let's put that f of 1, that is z is 1. Put z equal to 1. This is equal to log of 1 plus constant. Log 1 is 0, so this is equal to constant. So now f of 1 is equal to iota, that is given. So iota is equal to constant. So thus this fz, this f of z जो कि हमारा यह था log z plus c, instead of c you write the value for c, that is c is equal to iota. So this is f of z is log z plus iota. Okay, this is the required analytic function. All right, this is a very nice question. So it is now very clear to all of you that how to use MD method, that is the Milne Thompson method. And once again I should tell you that if u is a harmonic function, v is a harmonic conjugate of u, and if v is a harmonic function, then u is a harmonic conjugate of minus v. This should be very clear to you. Alright, so thanks for watching my videos for analytic functions. Here analytic function content is finished. So in my next videos I will be introducing the power series. So do subscribe for my more videos. The next content, that is the power series. Thank you. Thanks for watching. Thank you.